Hi everyone, this video is going to go over what an ion is. We're going to compare it to a neutral atom, talk about particular types of ions, why they form, and then how to predict an ionic charge looking at the periodic table. So let's get started by comparing what exactly an ion is to a neutral atom. Everything we've been studying so far falls in this neutral atom category. So neutral atoms, you remember, they have no charge. And that's because whenever we're doing calculations for our protons, neutrons, and electrons, you'll notice that the protons and electrons are the same. They're equal. And specifically, they're, in this case, equal to the atomic number. So it's neutral because the positive and negative charges are exactly the same. We'll look at an example in a minute. An ion, on the other hand, is a charged atom. And that's the definition completely boiled down. An ion is just a charged atom. So in this case, the protons and electrons are not the same. They are unequal. So the protons you can still calculate from the atomic number. That will be normal. The atomic number defines the element, but the electrons are going to be different. And so ions form by changing the number of electrons. We can't change the number of protons without changing the atom, so we change the number of electrons. So our blank below the chart, ions change the number of electrons. We've talked about before, we can change the number of neutrons and it makes an isotope. So now, if we change the number of electrons, we are making an ion. Let's talk about the two different types of ions. So ions can form one of two ways. We'll write this off to the side. They can form by, number one, gaining an electron, or electrons, and number two would be losing electrons. So if we're changing the electrons, right, we only have two options. We can gain more or we can lose some. So let's start with cations. I know it looks like cation. It's not. It's cation, just like the animal cat. A cation is a positive ion. And a couple different ways to remember that. So option number one is it's a positive ion, like cats have paws, so positive ion. Or you can remember, if you don't like cats for some weird reason, that the T kind of looks like a plus sign, and maybe that'll help you remember it. But cations are positive ions. And if you've ever seen a cat play before, maybe they jump up on like a coffee table and you have like your keys sitting there, and then they start like batting at the keys, and now they've lost your keys. If you've never seen it, look up cat videos later and then enjoy that rabbit hole for a while. But anyway, so cats lose things. So a cation is formed by losing electrons, which means if you are losing electrons and it's positive, you have more protons than electrons. So if you have more protons than electrons, you have a cation because there's more positive charges than there are negative charges. And on the periodic table, certain types of elements form cations. Metals will form cations as well as hydrogen. They both form cations. So metals and hydrogen, which means if you're looking at the periodic table, we'll draw a little bit of a staircase right here. So over on this side, we have our metals. Except hydrogen. Hydrogen's a non-metal, but everything on this side, this is going to form a cation. These over here, they really like to lose electrons and form cations. Okay, let's go back and talk about anions now. So an anion is a negative ion. And to help you remember it, I've got a couple ways so you can choose what works for you. Anion, kind of like an ant. Their antennas kind of look like little minus signs right there, so you can think of that as a negative ion. Or some people like to think the word anion kind of looks like onion, and cutting up an onion is a really negative experience. You know, you cry when you cut up an onion. So whatever helps you to remember it, that's great. So if a cation is formed by losing electrons, an anion then is formed by the opposite. Anions are formed by gaining electrons. And to help you remember that part, think about worker ants. They're always carrying things around with them. So we're gaining electrons, we're adding it to them. So you can picture little electrons hanging out on the ant's back. Next, in terms of protons and electrons, if it's more negative, that means we're going to have more electrons because they carry a negative charge. So in this case, we have more electrons than protons. And on the periodic table, these are typically formed by non-metals, except for hydrogen, which is a non-metal but forms a cation because it's an exception to basically every rule, it feels like. Okay, so quick recap. Neutral atoms, protons, electrons, same. Ions, we have a charged atom. Protons and electrons are not the same, and we form them by either losing electrons, form a cation, or gaining electrons and forming an anion. So let's now look at a quick example of Bohr models to see how a neutral atom compares to an ion. So we're going to look at boron and then boron 3+. So boron is right here on the periodic table, has the atomic number of 5, and it has a mass number of 11. So let's take a look then at a Bohr model. So boron with a symbol of B, and then boron 3+ will have a symbol like that. We write the symbol up into the corner to show that it's an ion. So for both of the borons, the protons will be the same. The protons for each are going to be 5, because the protons are what define the element. So those have to be the same. Neutrons, in this case, we're just going to use whatever we've got from the periodic table. We're not going to do isotopes and ions together. That would be a bit much. So the mass number is 11. 11 minus 5 would give us 6 neutrons for each. Here's where things get a little bit weird. You guys are used to the atomic number equaling the number of protons and electrons. So normally, when you saw a Bohr model of boron, you would say, we've got a total of 5 electrons, 2 in the first, and 3 in the second. And that would be a neutral atom, right? Because the protons are 5, the electrons are 5. Those things cancel out for an overall charge of 0. If we look at boron 3+, this cation of boron, well now, if it's positive, we know that we have more protons than electrons. And specifically, we're going to have 3 more protons than electrons. So if we do a quick little math equation here, and we're thinking that, okay, there's 5 positive charges, and we're figuring out electrons. Well, it's a cation, more protons than electrons. We have to be more positive. That means by 3 more, there's only going to be 2 electrons this time. So this is what boron 3+ looks like. So now our overall charge, we've got 5 of these positive charges. We could think of it like this. So if protons are 5, electrons are 2, you've got 1, 2, 3, 4, 5, and electrons, we only have 2. Well, those cancel each other out, and here's where we get that 3 positive from. So why do ions form anyway? Why does boron want to form this 3+ charge instead of saying neutral? Like, it would seem normal for them to be neutral, but it's actually not. Boron like this is incredibly unstable because its electrons aren't happy. Certain electron configurations are more stable than others, and so boron wants to become more stable. So ions form to become stable, and specifically, all of them want to have 8 valence electrons. And you're going, well, wait a second. The boron example you just showed us doesn't do that. It only has 2 valence electrons. I know, hang on just a second, I'll explain that. But for the most part, All of our elements want 8 valence electrons because 8 valence electrons means you have a stable atom. So it's stable. And this rule has a specific name. So this desire for electrons to become 8 or 8 valence electrons, it's called the octet rule. So this is called, and this is super important, this is called the octet rule. And that rule is just saying that atoms really want to have 8 valence electrons. Oct meaning 8, so 8 valence electrons. Okay, so now let's talk about why the heck boron only has 2 valence electrons then, even though I'm telling you that 8 is what we need, right? Okay, so think of another element that has 2 valence electrons. Another element with 2 valence electrons would be helium. Helium only has 2. Helium is a noble gas. And if you notice, the rest of the noble gases have 8 valence electrons. So the most stable that boron can get to is to go back a few and become helium with only 2. Everything else after that will want to go to be like a noble gas and have 8 valence electrons. But helium also stable, just with less electrons. Okay, so we talked about that metals typically form cations, and then we've got these nonmetals over here, and they typically form anions. Here are some typical charges that you will see. Just like how valence electrons have a pattern, so do what we call oxidation numbers, and an oxidation number is just whatever the ion's charge is. So like this would be the oxidation number, the ion's charge. Anything in the first group likes to form a 1+ ion. In the second group, they like to form a 2+ ion. We're going to skip this middle part here for the same reason that we skipped it for valence electrons. It's going to be polyvalent in here, and so they just play by their own rules. We're going to skip them for now and then come back to them a little bit next unit. So group 13 is 3+. Group 14 is a 4+ or minus. They can go either direction. And then group 15 forms a 3-, 16 is 2-, and then we have 1-, and then our noble gases are 0 because the noble gases do not form ions. They don't have to form an ion because noble gases are already stable. Everyone else is trying to get 8 valence electrons, and they're over here on the periodic table being like, haha, I already have 8 valence electrons, I'm good. So they don't even form ions because of that. So this ionic charge, this oxidation number, what that's telling us is how many electrons are lost or gained. For example, when we were looking at boron 3+, that told us that we were going to have to lose, because it's positive, 3 electrons. So it's a positive ion. We lose electrons. We lost 3. Let's say we're looking at beryllium to the left of it. So beryllium, it's positive, so it's losing electrons. It would lose 2 electrons. Well, what about something that's negative then? Something that's negative like oxygen, more negative, more electrons. It's going to gain 2 electrons. And the whole reason that ions form in general has to do with the number of valence electrons. So you can kind of notice a pattern here. Something that has 1 valence electron over here, it's trying to lose 1 valence electron, because as soon as it loses 1 valence electron, well, now it reverses back to a noble gas configuration. Something like in this group here, they have 7 valence electrons. If they just get 1 more valence electron, they're happy. They really want another valence electron. So they gain 1 electron so that they can become like the noble gases over here. So it's all about how many valence electrons they have and how many they can get to. Let's do some practice problems together and make sure you're understanding what's happening. So first, you're going to calculate the protons, neutrons, and electrons for phosphorus 3-, Number 2, what ion will arsenic form? So I'm talking about the oxidation number. And number 3, how does chlorine form a 1- ion? Go ahead and pause the video and try these, and then watch for the answers. Okay, up first we have the protons, neutrons, electrons for phosphorus 3-. So phosphorus's element tile looks like this. It is number 15 and has a mass of 30.97, so we'll just put 98. But while that's the element tile, we also have this 3- to deal with. So we're going to do protons and neutrons like normal. Protons are going to be 15, and neutrons, this rounds to 31, and 31 minus 15, we get 16, so there's 16. For electrons, we notice that we have an anion, and we remember from the notes that anions have more electrons than protons, which means we are going to be gaining electrons. And specifically, we're going to gain 3 electrons because this number is 3. So we're gaining 3 electrons. We would normally have 15, right? Because that's the atomic number. But now, since we're gaining 3, 15 plus 3, we actually get 18. So a way to remember it, whatever the sign is on the ion, just do the opposite to your electrons, right? Like if you have 15 as the atomic number and you see this negative sign, well, that means you're adding 3, and vice versa. Next, what ion will arsenic form? So arsenic is right here. It is in group number 15, and it will form a 3- ion. So arsenic will form As3-, and this is an anion because it's negative. The last question, how does chlorine form a 1- ion? So if something is minus like that, we know it's an anion. So chlorine forms an anion, and we know that anions form by gaining electrons. So chlorine forms an anion of 1- by gaining 1 more electron. Okay, so quick recap. You guys know the difference now between a neutral atom and an ion. You know the difference between the 2 types of ions. We have cations that are positively charged, and we have anions that are negatively charged. You can draw a Bohr model and calculate the protons, neutrons, and electrons for neutral atoms and ions. You know that ions form to become stable, and so because of that, noble gases don't form ions. They are already stable. You know that metals typically form cations and nonmetals typically form anions, and they're doing that because they want to become like a noble gas. They want to have 8 valence electrons. And then that charge we can see from our pattern, that is going to tell us how many electrons are lost or gained in that atom. All right, that is it for your notes over ions.